have you ever wondered why the scientists or the engineers used to say that microplastics are impossible to remove out of the drinking water? You might have thought it's just getting harder to do so due to its smaller size, but you don't know that the most drinking plants were never designed to catch a plastic that small. When the people hear microplastic, they imagine tiny plastic bits floating in the water. But the reality is much worse because the microplastics are fragments smaller than the 5 millimeter in the size, far smaller than that, down to the size of bacteria, are the many more microplastics that we can't even think of. They come from tire wear, synthetic clothing, degraded packaging, and even some other personal care products. Once they enter the water system, they don't dissolve, they don't react, they don't biodegrade itself. And from a perspective of a chemical engineering course, or I can say chemical engineer, this creates a nightmare for a separation problem. Traditional water treatment relies on the sedimentation, filtration, chemical coagulation, as we discussed in the past few shots. These processes work well for the sand, dirt, and microbes. But microplastics sit in the awkward size range, too small to settle, too large to behave like dissolved solids or molecules. Many of them are also buoyant, they float, tumble, or slip through the filters that were never designed for the irregular plastic fragments. Membrane systems can remove some microplastics, but they come with a trade off, as we always do. Discuss that membrane systems require higher pressure drop or more energy use to make them effective. And the same is here, higher pressure drop, fouling, and the more energy use can't let the membrane last forever. More like wastewater plants can capture a large fraction, but not all. Whatever escapes ends up in the rivers, oceans, and eventually in our food chain. Researchers are testing advanced approaches like electrocoagulation, magnetic particles, and the surface modified filters. But scaling those solutions safely and cheaply is not still an open option. It's still a challenge. That's why even highly developed water systems still contain traces of microplastics. And it's not negligence, but a simple physics, material sciences, and transfer phenomena colliding with a problem we didn't design for. Microplastics are hard to see under a microscope. They are hard to separate in real world, and that's why we are getting the problem of not able to separate microplastic from our drinking water chains. Follow for more chemical engineering and technology facts explained very simple. Bye bye.